I was jamming out to the music there. Hello, everyone. Welcome to Howdy Partner. I am James Spencer. I am your host, one of your hosts, and a partner solutions architect here at AWS. What is Howdy Partner? Howdy Partner is our weekly show where we bring our partners on and they show us what they've done with AWS and shown us the beautiful and wonderful products that they have built and how you can use them to increase your productivity, make life easier, anything. We actually go behind the scenes, get behind the diagrams, get everything, and do hands-on demonstrations. And today, one of my co-hosts, Mr. Aniket. Aniket, are you there?
Hey,
There you are.
James. Hey,
Hello.
thanks for having me on the show.
No, thank you. Thank you for coming. Uh, you want to tell the people who you are?
Yeah, absolutely. I work with James. I'm a partner solutions architect here at AWS. And I basically work with partners to help them get started on their journey on AWS as well as build some innovative solutions on AWS.
Beautiful. Nice. So who are we talking to today? qBraid? qBraid. They
Yes,
they do quantum computing. Um,
absolutely.
Aniket, what is quantum computing? How does AWS do quantum computing kind of stuff?
Yeah, so we have our partner qBraid today who have leveraged an Amazon service designed specifically for quantum computing. It's called Amazon Bracket. So Amazon Bracket allows you to leverage the cloud technology to run your own simulations or get started with quantum computing. You can use the SDK to create your own algorithms or use some native algorithms, pre-designed native algorithms. So we're just excited to learn how qBraid leverage this.
Yeah. I know for myself, I'm not an expert, so I am looking forward to learning everything from our partners at qBraid. You want to bring them on? See, maybe they can help us out here.
Absolutely. All right.
Hi, welcome, Ricky and Perminder. If you want to introduce yourselves and tell us what we're going to talk about, Ricky, maybe you can go first.
Sure. Hello, James. Thank you for the warm welcome. And Aniket, awesome to be on Howdy Partner. My name is Ricky Young. I work at qBraid. And today I'll be showing you guys around qBraid. And hopefully at the end, we'll be able to show off some of our subscriptions that also utilize EC2 instances and EKS as well.
Beautiful. And Perminder, who are you? Tell the people.
Sure. Thanks for arranging this. Myself, Perminder, and I live out of Dallas, Texas, and I am spearheading the quantum initiative with our ISV partner like qBraid since September of 2022, and have done a lot of consulting in my life. The quantum is probably a year or two old with me, and I am actually studying my master's in quantum computing out of
Nice.
university in Madrid. Um,
Oh,
and we talk with some of our ISV partner like qBraid, how to build these solutions. And this is an interesting solution. And then let's dive into it.
yeah, for sure. Take it away. You're the professionals. I'll leave it to you.
Awesome. Great. And do you mind if I just start off with the presentation? It's only like 5 slides,
Oh yeah.
kind of getting into it. Awesome. All right. And first off, I'd like to kind of ask the audience as well as everyone here whether they have maybe used any kind of quantum computing before or have used some kind of software that involved Python. And if so, if they've ever encountered a dependency issue or some kind of issue with when it comes to package installing. I certainly have, and I think a lot of us at qBraid have as well. James, were you about to kind of chime in there?
I was gonna say I don't have that. I haven't don't have a ton of experience with quantum computing, but dependency issues. Oh yeah, like that's get any developer if they haven't run into a dependency or package issue, they're lying to you. So
Hey, that's why I stick to Hello World programs only, because
yeah,
there's no
right.
dependency there.
So,
Thanks. Perminder?
So, what was the question?
Like in terms of your background, what have you ever ran into dependency issues? I know you did a lot of machine learning stuff, so I would assume
Yes,
you did
yes.
the
So,
TensorFlow gamut.
my background is primarily open source, but before that, I did a lot of software engineering and dependency there to us being as an architect, the dependency injection, the whole UML style of programming, right? So packages in the .NET and all, a lot of things we used to do like one of the 15 years ago, .NET or Java has this dependency in a different way. You could fast forwarding Python is a little bit of different way to do this, but yes, I have a fair idea.
Awesome. So if everyone can at least agree with that, dependency suck to a certain level, we're in the right crowd. And all of you guys who are on the chat, thank you for voicing your complaints and concerns as well, because qBraid is here to kind of fix all of that, hopefully for at least the quantum software development. If you could imagine the quantum software is really early and very early, people are making a lot of changes that perhaps could even involve a whole module disappearing. And then imagine coding on a certain version of quantum computers, then you can actually imagine that the software might actually end up basically breaking the next time you upgrade. So the reason why quantum computing with qBraid is going to be easy is because we've kind of improved the access quantum software, the access to quantum and classical compute, as well as we're trying to build a lot of these like quantum specific software without the dependency issues.
Mhm.
So all the classical side of all the work that you're doing is now just like disappeared because you're now focused on just writing Pythonic code in the specific frameworks or quantum computing packages like Amazon Brocket and accessing them without any issue. So that's our ultimate goal.
Hey, Ricky,
Yeah.
just real quick,
Mhm.
did you want us to show your screen, or I don't know, did we get to that point yet?
Yes, I think I might have just not shared my screen. So let me actually share my screen.
It's all good.
Great. Can
Just
you all share my screen?
beautiful.
Yeah.
Okay, yeah,
Great.
there it
We
is.
see it.
All right, so that was the that was the cover slide that I was supposed to show, and then these are kind of the bullet points that encapsulate the pain point that qBraid is trying to tackle as a IDE of sorts or a development platform. Any questions so far
I
today?
when you say IDE, like there's an actual there's a million, there's a million IDEs.
Yes.
There's a qBraid IDE as well.
Yes, qBraid is an IDE. We'll show you guys how to work on it. And in fact, James and Aniket, if you guys want to join in, I know you guys are handling the screen share and a lot of the controls for the show, but I would love to show everyone that it's really easy on qBraid. In fact, you can get started on Amazon Brocket in less than 5 or 6 clicks. So,
Wow.
yep.
Okay.
Yeah.
And you run your own quantum computer and your own quantum program with that. So,
Yeah.
with that said, right now, a lot of the current problems that we face is that there are various providers of quantum computing, as well as there's like not really easy ways of accessing quantum algorithms and simulating them, as well as there's a lot of work that needs to be done with error mitigation. Most of this is perhaps a lot of work for PhDs, especially for the figuring out the error mitigation, and they often work in Jupyter notebooks, which are essentially a coding file that includes Markdown as well as code cells. And it's a lot easier for people who are on the research side to use those. And that's why qBraid is actually based off of Jupyter Lab, an open source platform. So our solution kind of encapsulates Amazon Brocket as well as other providers, all as well as GitHub, all onto this Jupyter Lab IDE. And we also have an SDK I'll show you guys later, which allows you to not only make a Amazon Brocket circuit, but also a circuit in Qiskit, for example, and then transpile it and send it to various devices as well.
Yeah,
So this is kind of the write once and target technology that we have developed.
yeah. And there is a reason why this solution stands out, why you need this solution. So if you ask a circuit designer or algorithmic developer, right? I mean, we all are Pythonic in a way, right? We go and start coding and then run the Jupyter notebook, pip install, all looks great. But then how do you transition from that research or your pet experiment which you are running towards a production grade environment, right? It takes a um, probably a lot of man hour to do that. If you do it yourself, you have to think about like which Python environment to choose and things like that. How do you make sure the research engineers are cross collaborating? And then this is where the software was built in that mind, right? Like let us take the some of the management overhead away from the developers and create abstraction layer, right? Like and then a GUI, a graphical user interface, the IDE, and those were the primary driving factor, right? Like 20 years ago when we were used to be in a pre-.NET, pre-Java environment, a lot of the progress on those programming language happened because there was an IDE behind it, right? And then fast forwarding it in terms of Python, PyCharm or Eclipse. So that made developers' life easy, right? As well as the operational guys' life easy. And so we saw this DevOps fit into it. I think in the quantum space too, as it get mass adopted, so sooner or later, tools like this would be needed so that developers can focus really on the circuit rather than getting in the weeds of infrastructure, managing those. So some of those things you will see. Over to you, Ricky.
Thank you, Perminder. That was actually so well said. Really just encapsulates what I wanted to say, but Perminder is a lot better with his words for sure. So essentially, this graphic you see here with all these lines is essentially that optimization for a lot of the people who are looking to use quantum computers, where they will not have to spend all the time perhaps like writing circuits over and over, or say using one package and their features and then having to convert it later by rewriting everything.
When you say circuit, what is that? What exactly is a circuit?
Yeah, that's a great question. So the computers that we mostly have on our platform are called gate-based quantum computers, where you take an equation called the Hamiltonian and you describe them using essentially operations that you can use on a qubit, which is a quantum version of a bit. So a bit is the zeros and ones you have on all the computers that are running this world. Well, running not on for this world, but you get the point. And
Yeah.
quantum computing, we use something that has a little bit of a new paradigm where you use quantum mechanical properties such as superposition entanglement to get a probability distribution between 0 and 1, where you can get something such as like when you apply the Hadamard gate, you can actually get a probability of being 50% 0 or 50% 1, which allows you to do a lot more calculations as well. Does that make sense?
For the most part, yeah.
Okay.
Yeah.
Yeah, there is an easy way to explain this to the community, right? The superposition, you will hear, what the heck the superposition is. There is a math behind it, but there is a famous or a loose analogy. We all have electric switches at home, right? There is on, there is off, zero state, one state. We also have a dimmer nowadays. So you can dim the light, increase the intensity or decrease the intensity. You can go to 0, 1, or in between. So treat it like that, like you have superposition. And if you want to know math behind it, if n is a number of digit, and if you say 2 to the power n, and n being 2, so literally you have 2 to the power 2, 4 states in parallel, and the probability decide like which one is the right answer and all that. But I often give this very loose analogy to the newcomers how to even picturize superposition. It is sometimes difficult. It took me a while, right? Like I was in a classic world for 20 years, and then when I started going into this whole quantum, I was like, what the heck is superposition? So I heard someone giving this analogy, and it was very clear, because if you start imagining and then start relating it to the actual real world examples, so this hard, complex mathematical formulas come naturally to you, and sometimes it is easy for the students, right? They are out of high school, they get it, because they don't have to unlearn. Person like me, 20 years
Ah,
baggage,
yeah.
I have to unlearn all the bits and then position myself into this whole new way of thinking.
I actually had on the same line a question to you, Parminder and Ricky, because I'm not an expert in quantum computing. I have no idea how it works. But does anyone need to learn like quantum computing in order to use qBraid solution?
We actually will, in the demo, show you, I think that's a great place to start. We actually will show you our course, which is endorsed by the White House Q12 initiative and various other platforms that are also meant for enterprises for upskilling as well. So these are some of the things that we offer that allow for anyone to get into quantum, and then further on, the SDK will show how you can dig deep into quantum as well.
Yeah, and then K-12 for those folks who are not from US, right? So the grade here are defined by like back in India or other places like kindergarten 1, 2, 3, 4, so 12 classes K-12, and this initiative which Ricky is mentioning, White House means it is a big deal, right? Like means you have official listed as a quantum software where your kids from high school or college viewers can get access to and get trained is a big thing. So
Yep.
that was one of the highlight from last year. Uh, but it is a good, like we have to give free access to the student and the community because a lot of firepower is needed in this, right? I often say sometimes we underestimate the power of new technology, right? And then you need this whole crowd intelligence and these high schoolers, these university students, they will be the key. No, I will retire probably in 20 or 15 years. These are the guys who will be probably spearheading, fast forwarding 20 years from now. I think like I'm very positive, very optimistic. Some of these things get replaced on the classical side. We have the quantum computers probably everywhere. That is what I think like a futurist. I may be wrong. It may probably take 30 years, but these students who are part of this, part of this like in education system, they are the smartest of the smartest. They get this concept of superposition like anything, right? Like means you are like I have seen, I have competed in some of the hackathons and then even the coding school. Some of them are literally like out of their 10th grade, some 12th grade. Very smart bunch of people, right? And you need all of them. So, but how do you bring them into this fold? You need some easy way to learn the concept, right? So, because math and physics, if you attack it from that side purely, it becomes like a number game and a formula game. But then you need all of those, right? But if you start at a level, you abstract that and then show like how easy, sometimes it's easy to design the circuit and all, math and physics will follow because students are great at that.
Yep. And we'll definitely get all into all of that a little later on. And so just to move forward, so with the qBraid SDK, you're going to see this kind of environment manager panel. These are essentially pre-packaged Python environments where we have all the packages pre-installed, and then you can also add your own packages if you'd like. And this makes it a little bit easier for managing your quantum environments, so these packages. And not only that, but we're able to demo how to enable quantum jobs as well. So that will show you how to use quantum jobs with Amazon Broadcat without the need for IAM roles or building out your own account. You can just make an account with qBraid and boom, you're like ready to go.
Beautiful.
Awesome.
So yes, and then this is just another slide about the SDK. And these are currently we have AWS, and then we have the Qiskit simulators available, as well as Circuit and a few others as well. So this is kind of the selection we offer, and we'll kind of get into which ones are available today, because quantum computers right now require essentially a lot of tuning and many physicists and engineers to make sure that they run smoothly. So they have a bit of some downtime. All right, and if you'd like to learn more about it, you can check out the link below on the qBraid SDK integration with Amazon Rocket.
I just also want to highlight that Ricky himself wrote this blog, so kudos to your technical writing skills as well.
Oh yes, it was myself, Xiaofan, Perminder. I think Jordan was also in it.
Nice.
And yeah, it was super fun. I think writing these articles is always great. So, all right. Without further ado, James, or Aniket, or anyone would like to join, would love if everyone could go to account.qbraid.com.
Sure.
And
Absolutely.
Aniket, if you could drop that chat.
So, let's open this up here.
There you go. And once you have done so, then we go to the profile page. You can edit your own profile. This is something that I can show a little bit later as well. And at the bottom of the account details page, you'll see an access key where we will add today's access key, which is EHMU 6626.
Ah, okay.
All right, so.
Do I have to? Sorry, Ricky. Do I have to
Yeah.
create my own account?
Yes, please.
Okay.
Yes, create your own account. At least it doesn't require a credit card. We're trying to be as friendly as possible, but also we do have subscriptions now as of very recent, and we will provide a lot of variable compute as well. So. All right. All good?
Where do I put in the access code again?
Yes. So there is the account details, which is the second link in the private chat. So this one. There you go. Here.
Okay.
Yep.
Yeah, let me drop that in for.
I got it.
Okay.
Sweet. And you can submit it.
Sweet, I already have 1,000 credits. Look at me.
There you go. Right. You have 1,000 credits, and these credits are essentially just as good on Amazon Brocket. So you are going to be using them for Amazon Brocket quantum computers, and it's equivalent to $10. So that is the equivalent to $10. And I think Perminder mentioned some great things about how qBraid is trying to empower various communities. And one of the really unique features of the quantum computing community is that we love hackathons. We really, really love hackathons. I think we have a hackathon going on right now with Xanadu, which is a quantum computer that uses, it's a photonic quantum computer that is available also on Amazon Brocket. And we just had MIT IQuack, which was at MIT, where we had another quantum computer that's also available on AWS, which is qEra, which is a cold atom quantum computer. Both of them are also available on qBraid. And we also had our very own. So I'm just going to talk about the first. So this was the Hacks Hackathon that we did. And if you are interested in getting more into quantum, these are great because we provide challenges. So we had people present at their own challenges. We had a little bit of a leaderboard going on, and we essentially tasked everyone to use a Amazon Brocket state vector simulator and try and run a variational quantum classifier.
Yeah.
We'll be probably doing this next year as well, and you see that there were some people from AWS that were speaking, and it was like a ton of fun, simply because, you know, who doesn't love just kind of spending 2 weeks just coding on a quantum computing problem, right? So
yeah,
yep.
That's cool. I like that there's a leaderboard. It reminds me of something we have called Game Day here at AWS.
Nice.
Those challenges.
Nice. Is this coding as well?
Not exactly. Well, some of it's coding, but
Gotcha.
yeah, it's just you jump. I'm not trying to get away, but you just jump into an AWS infrastructure and try and fix it, and you get points, and
nice.
It's kind of competitive like that.
Awesome.
Just real quick, for anyone tuning in right now, just joining us, we have qBraid with Mr. Ricky Young joining us, and he is showing us qBraid's quantum computing platform. If you'd like to join in, we dropped some links in the chat, and there's an access code that will give us $10 approximately of credits. So please join in.
Sweet. And if you want to know a little bit more of the hackathon that I was just mentioning, which was the one that Amazon Broadcast and ourselves qBraid did, you can kind of take a look at everyone's work on GitHub. It's all there. And then I'd like to get into one more feature, which is the Learn platform. So we also mentioned that there's a course. It's completely free and available for anyone. So if you're also looking to learn more about quantum computing, we have a course that is available for you. And what's really cool is you can actually edit the code and run it yourself. We have some interactive widgets. Maybe I should put something a little bit more appropriate. Howdy Partner. There you go. So you can actually edit this code and run it. And we have various quantum computing concepts taught by our team members. And we have multiple choices, questions, and other widgets available. So if you're into quantum computing or just getting started, this is also one great way to get started on qBraid.
Right. And I'm sure some of the students have joined us too, right? Like, and then some of the professional too would probably be wondering, like, how this get. Sometimes they ask us this question, like, how do I start? Where do I start? So, folks, this is this whole Learn platform on the qBraid, right? Like some of the pre-rec. Sometimes a person like me, right? Like means 2 years ago when I was delving into, as I said earlier, I had to brush up on my math skill. The vector, how does column vector, row vector, matrix, and all. Some of those is needed, but a place like a central place like this under qBraid helps to quickly learn those concepts and then move on to the some of the circuit designing in the quantum computing side, right? Otherwise, like you can always start here, get a common baseline, and then some fundamental set, design the circuit. You can always go back and refresh on this, or refine your, with advanced math needed or physics needed. But for a student, if I would have found this resource 2 years ago, I would have used it, right? But I was doing it in a hard way. So my recommendation is explore this local, non-local games. There is like a famous Magic Square CHS game, right? So those are also probably very neatly explained here. Some of the advanced algorithm, those who comes from the mathematics, right? The HHL or the Grovers. Sometimes it's very hard to understand, right? You may have to read it twice or thrice, but under a common roof, you are getting a concept, and then immediately you are going to try that in a circuit, right? So it's a fast learning process. So you can actually go back and forth. Otherwise, like I will be searching on Wikipedia what Grover is, and I'm coding somewhere, so and I lose the track. So that is what I wanted to say. Over to you, Vicky.
Oh, I think Ricky, you're on mute.
Awesome. Thank you, Perminder. We do get a lot of people who mention to us that they wish they knew qBraid a little earlier because, as I will show, there's a lot of features on qBraid that make your days to getting started on quantum and then working with quantum computing a lot easier. So with that said, I'm going to go back to our page here, and I'd love everyone to click on the Launch Lab button. So at the top right, you have the Launch Lab button. And this will take you, the first time it does take a little while because we're going to load in all your data as well as all the features that we have. And with this, you actually get a Jupyter Lab, as I mentioned before. If you've seen it in your data science days, or if you have worked on this in perhaps when you are working with machine learning or AI, it's very familiar. In quantum computing, we also use the same kind of platform, but we've added our own kind of twist to it where we have the Environments tab. And as I mentioned before, this is the Environments tab that was in the slides. We manage your quantum computing packages as well as available packages all through this environment, which you can also add your own. And You probably won't have this many as I do because this is my personal account and I use it frequently, but all you have to do is go to the add button, and in our case, we would love if you could add Amazon Brocket. I will be adding QTech. And if you could just install the Amazon Brocket environment, you will see that it will be installing right now. And once it's installed, it will kind of look like this. And you will have the Amazon Brocket kernel and Amazon Brocket Python environment available to you. If you're interested to know what's inside this package, you can check it out here. You can search for which packages are inside. So we can definitely check that Amazon Brocket is in here. We can also check if, say, matplotlib is in here. Perfect. But maybe Seaborn is not in here, for example. So if I really want to use some nice visualization, so I can actually just add the Seaborn package, Seaborn, click enter, and just install. So we have like the GUI for installing packages, and we also have our own CLI, which we'll get into, that will allow you to also activate and work with the environments as well.
Yeah. And see that, like, Ricky, right? Like if I was doing it through my local Anaconda, or I manage a notebook and a Jupyter notebook and a AWS console. Sometimes, like, making this requirement TXT file, dependencies about the versioning and all, 3.9, 3.6 Python, it can be done, right? And some of the techie do this, they automate this. But some other folks don't want to do that. They want to use the power of the GUI, right? And they can easily maintain those packages because their goal is to go and write the circuit for phase estimation, or the Grover algorithm. Their focus is not to make sure like all the versioning are correct, or they waste their lot of time, right? And I used to do often 2 years ago, maintaining my local environment and Python and all that. This is a quick starter in my mind. Like if you want to just go log in, create an account, pick up a bracket, you are ready in like 5 minutes.
Exactly.
We are here because you want to explain, but within 5 to 10 minutes you will be up and running.
Yep. And not only will you be up and running, but this is great if you are a team, because we also have a feature that allows you to share the notebooks. And perhaps when you're working solo on your local computer, you can actually, and I use a Mac, but someone uses a Windows, you can actually experience some issues there as well when you share a Python notebook. And with qBraid, you are guaranteed that it will run as long as you share the notebook and they use the correct environment.
That is a good information, Ricky, because not only the students, right? Think of like enterprise customers and the research scientists or the big pharma, right? Like someone in Tokyo is collaborating with someone in Madrid, right? Like, and they have to actually they're working on really molecular decomposition or some hydrogen or hydronium, right? Like, and then I work in my daytime, and then I want to share the result back to the person in Tokyo, right? Like, so this sort of thing coming out of the box is very vital for those distributed team, right? Otherwise, like you have to do somewhere else, maintain those IPython notebook, and then but you get this out of the box. So that is the power of the software.
Exactly. So we've taken a lot of the classical components and cleaned it all up. So I just got a nice notification, Seaborn has been installed. I didn't even have to really, I could have just been doing something else. I could install various packages in various environments and keep going. So as Perminder mentioned, we also provide, if you are, James, if you're on your account and you've gone to lab, you should see qBraid tutorials, which we have Amazon Brocket tutorials as well. And in these tutorials, so various quantum computing tutorials are already available for you to get started. You can run demos on quantum phase estimation, as Perminder mentioned, through Google. And I think Qiskit has some community tutorials, which we have also added as well. So today we'll be getting started with Amazon Braket, and we'll be showing off how you can get started with a quantum computer really seamlessly. So first off, I'm going to activate my Amazon Braket environment, and then going to select it here. In doing so, you'll be able to now select which kernel you're looking for. Very similar to the experience that you use on Jupyter Lab or Notebook.
Yeah.
I think one feature that we are trying to do is just like if we could just detect the notebook and what's relevant to it and give you the best one, because we do lose a lot of users. They get lost when you have to activate it and you have to change the kernel. We're working on that. So, yeah. All right.
Yeah, this looks. Yeah, I've used Jupyter a little bit, and yeah, this so far this is looking, kind of familiar.
Yep. And if this tutorial looks familiar, perhaps Perminder has seen it many, many times. This is actually Amazon Bracket's very own tutorials. We've added a little bit of our own spice to it. And so what this is if you run this line, which I think the syntax might be a little bit different, but as long as you run this line right here, qBraid jobs enable Amazon Braket, you're ready to run quantum jobs with Amazon. That's as easy as it is. That's it.
Yeah.
So no undifferentiated heavy lifting there.
Exactly. There's no heavy lifting here. And in fact, I was fooling around, but you actually don't need to put in your S3 buckets as well. So I'm going to set those. And then we can get all the gates that are supported. So you can really think of these as like essentially computers that are still working at the gate level. And each of these computers have various different architectures, so they have specific gates that are available to them. So you have to actually take those gates that are available and the gates that you can actually code in and then translate them as well. So there's actually some exciting research going on there as well. Okay. So we've got all the devices that are available. Now we're going to run a simple Bell circuit, which creates a maximally entangled state. And we are going to run this in Amazon Braket and a local simulator. And if anyone has a question, just let me know. We get our results back. And now we're going to actually take a look at the quantum devices that are available to us. So we have the Amazon DM1, SV1, TN1, and the IonQ device. All right, let me just, what I'm going to do is just take this device ARN. Oh, it's already there, but copy it in. And now, although it says Rigetti, we're actually going to run this on IonQ. So we can now just submit a job to IonQ and get our job back, which is really great. So once the job has been queued, I can take a look here. I see it's been added in, double check. And whenever this job is completed, I can actually just stick it in here and grab my job. So that's it. You just ran on a quantum computer, Bell circuit.
So Ricky, how many jobs can you run at the same time?
That's a great question. So you could technically run as many jobs as you'd like, but there's a queue. So that queue itself could actually hinder your ability to get all of your jobs completed, as well as the cost of some of these devices can be very expensive. So you can imagine that might be a big inhibitor as well.
Yeah. I mean, as a circuit developer, right? Like, you always want to test on a simulator first, right, before you start hitting the QPU, because there is a cost element to that, right? And these are some of the premium resources which we have under the bracket, like five QPUs, four modalities. You don't want to just run your first trial and then hand it over to QPU. You want to probably test it out on the simulator first. Once your confidence level, your circuit is good, then you want to hand it over to the QPUs, right? And then you can always do the benchmarking, whether it's the classic versus quantum, if your algorithm like that, or between the different GPUs which you have. But start and there's a local simulator too, right? So you have to go in that order because cost can be very quickly it will go. It is a premium resource, right?
Yes.
So
Yeah. That's always the first question is always what does it do? And then after you explain what it does, next question, okay, how much does it cost?
Yep. That's fair. And as Perminder mentioned, like quantum computers right now are expensive because you have a lot of smart people working on them, engineering them, and it's not entirely Amazon Brocket's fault. But it's really just simply the fact that these computers are super large,
Yeah.
and people are working on them and whatnot. So, and I think I use the state vector simulator all the time, both locally as well as the one online on Amazon Brocket. Because again, I think when it comes to using a quantum computer, it's probably best to just stick with the simulator and get your results, and you get like non-noisy results as well. All right. So I'm going to see if I can get this result back. Maybe it is going to take a little while, so it's queued. Let me see if I can grab an old result. Oh, going to grab the job ID. Go. Okay, that task has been completed. I'm going to then try and see if I can plot this task here. Oh, sorry. It's got to be a string. Right. And actually, this might be a task that uses spaghetti, which also implies that there might be some parts of this that won't be available. Okay, so let me actually just use a spaghetti task. I have.
I love that name, Rigetti.
Yeah.
Makes me hungry.
Same here, yeah.
Spaghetti. There you go. So you actually get and this is all provided by Amazon Broadcat. So this is the magic of Amazon Broadcat here. You get the compiled circuit. So this is the actual circuit that was run on the quantum computer. It may differ from the one that you actually coded because of the gates that are available on the device. You get the distribution of the shots, or essentially how many times you ran through the circuit. Again, you get a probability distribution, so every single time you get a different outcome. So these are the results that you get. And yes, so this is kind of how you would use quantum computers on qBraid with Amazon Broadcat. Then, if you have any more questions, if you have any more lingering questions, we have documentation of it as well here. So then you can actually visit Amazon Broadcat. Maybe I can drop the link here so then people can learn a little bit more about it. So
thank you. Thanks for that. Yeah, I mean, so those are the examples which our team put together. It's available in the GitHub too. And if you just follow the instructions and then use the qBraid platform, I think you can be a quantum knowledgeable or quantum deadly in a weekend.
Yes.
Depend how you see yourself, right?
Yeah.
I was hoping you'd say quantum expert, Perminder.
Yeah, I mean, no one is expert, right? It's the active area of research. All of us are collaborating, right? Like means
Yes.
a PhD scientist, a university professor, or a high schooler. All of us are learning, right? Problem is not new. Means there was an active research, or like last 100-year work was happening. Nowadays we are hearing more because there is a good progress made by hyperscaler like Amazon, software solutions like qBraid. You are abstracting out the problem and then focusing on some of the industry use cases. But before even coming to the industry use cases, the power of the software is going to be vital in the success of the hardware. Hardware is going to mature in terms of qubit and from NIST to fault tolerant. It will happen, right? But at the same time, we need solutions at a software level, and then the vertical solution too, as some of the companies are developing, right? And they have there has to be progress parallelly on those. You can't just sit idle and then think like, okay, after 5 year only, I will worry about when quantum computers are available, because you need to probably think about software where you can experiment with the simulator and whatever number of qubits are available in the hardware, and learn to live with noise and all that. Software programming goes over a change, right? Like means there will be a new programming language, new way of doing things. But software goes hand in hand with hardware. It is my belief, because quantum hardware will mature, no doubt. When we have to see, it's not if question when, but at the same time, software always play a vital role, and qBraid is that type of a solution.
Exactly. And when we are a solution, it may be for some of the more hardcore developers, they may say, oh, I don't need a GUI. I don't need to do all of this. I'd rather use a terminal. Well, we do provide a terminal for you. And in fact, we provide AWS CLI out of the box.
Yeah.
No pseudo app necessary, which is great. And we also have our own CLI. So in this CLI, you can actually enable a certain, such as the certain enable Amazon Bracket or qBraid M's enable, or sorry, activate. So we take the same as, there you go. So now you can pip list and get all of the Amazon Bracket packages that are available, or the ones that we've installed right here.
Okay.
And so you can almost treat it as if you're working just like another Python environment. And that's
Yeah.
also some of our strength as well.
Yeah. That's what did you I blinked for a second. What did you click to get to the
Oh,
terminal?
yes. This terminal is actually through this blue button. It's called a launcher.
Okay.
And here at the very bottom, we have our documentation,
Got it.
as well as our terminal here. And in here, we have qBraid CLI, which allows you to then, for example, enable jobs, enable for, I will say, the default environment. I need to activate it. So boom, that's it. I have just enabled Amazon Bracket jobs, and then qBraid ends. I can even list them out, and I can see, boom, I have jobs enabled now. I can disable jobs as well on the default environment if I want to use my own credentials, for example. And qBraid jobs disable defaults. Boom. And then if I list it out again, all right, it's red, and it tells me that I have to add in my own credentials. So then I'd have to do AWS configure or something. So there you go.
Yeah.
So yeah, this is the more, I am a developer, I like to use a CLI. Well, we have given you the CLI, and we provide you essentially very much like your own quantum computer, essentially your own, or sorry, not quantum computer, but your own like essentially remote computer that you can use to code is how we like to treat it.
Yeah.
What
Yeah.
about metrics, Ricky? Can I get like more details about a particular job, how long it runs for?
Oh, yes, we will be getting that very soon. That's a great point. So we don't have access to the queue, for example.
Mhm.
However, so if you're interested in learning more about what you have ran, we will be providing a little bit more details than this. However, you can always get more by using, for example, recovering your task with this code snippet that we provide. I can just copy this here, this, and say we'll pick this INQ1, and we can actually get more about this job by just entering the task ID and recovering it. And then I think I can actually just task load, and then you can see what the JSON that it returns is. Oh, whoops, quantum task ARN. Key error. error and response. I'm not entirely sure, but it should probably work if you enter in the correct one. So let me do this, job ID, on task, do task load state. There you go.
Mhm.
And you get your AWS Quantum task back, and you'll be able to treat this just like Amazon Braket and get your results similar to the tutorial that I just showed. So you can get your histogram back as well and whatnot. So
Yeah. And under the hood, as you mentioned, Jason, right, like it's a REST API call, right? Like going from qBraid to the bracket, and then all the JSON are getting back. So like there are like three layer, right? Like if you I have to picturize this, how the calls are going. So calls are going from the, uh, the compute instance in the AWS CloudWare's website is, right, and then where this Python notebook is running, and it's making an API call to the bracket endpoint, and bracket endpoint. And for the task, at least, bracket endpoint is going to the QPU over the wire, and those reals are getting back. And metrics and data, you can always go back in time and point, and then give the PRN ID, the task ID, and then you can fetch those values.
Exactly. And so with that, again, all of this is built with Amazon. So we have the Amazon EKS, and this is Docker file that we use on a more architectural perspective. And now I'd like to kind of show off our SDK. So I'm going to drop this link here as well.
Oh, sweet.
And what we do is, as long as it's a public repository, we have this button that you can add where we can actually just click on it. It will take you
Oh,
and
that's so
actually
cool.
just clone the repository for you and show you can actually just launch it on qBraid. And there you go. I see it on my left-hand side. We have the Git extension available too, so you can actually switch branches, or if you already have changes and whatnot, you can actually just keep track of it and treat it just like any other ID, where you can push and pull, commit, and merge branches and whatnot.
That's pretty cool.
That's
Yeah.
very cool. We had a comment in the chat asking asking about if we're going to be referring to any small-sized superhero movies that are out right now.
I don't recall.
Yeah.
Gotta love DC.
Oh,
No, I'm kidding. I'm a huge Marvel fan. So, but yes. Is it out already? Are we allowed to say that out loud, or is this?
oh, I
Know if
think
it's.
so. I don't
Oh,
know.
yeah.
It's
I
just
think it's
something
like
funny.
it's so cool because I think the Chicago Quantum Exchange also did like a movie viewing, and people kind of talked about
Oh,
quantum computing as well. So yeah,
that ties in pretty well.
yeah, and I think Chicago Quantum Exchange is also a partner as well with AWS, or AWS as a sponsor. Very cool. All right. For the sake of time, the SDK involves like 3 or 4 very large packages, so it does. I'm just not going to install it, but I can just show it off. If you want to, if you're interested, you can also, again, purchase a subscription. Then you'll be able to have access to the SDK and activate it and install it. And what it will do essentially is show you all the devices that are once again available. You can almost just filter for specific devices. And these are the same devices that you have available through our qBraid jobs, but we've kind of bundled it into our SDK as well. And again, as I mentioned, what's really, really cool is that not only do you get the information about the specific device, but if you write a Qiskit circuit, for example, we actually have a fairly robust transpiler. So Qiskit is the IBM quantum computing framework, and you can actually write a circuit here and convert it from a Qiskit circuit, run it on an IBM device, run it on a Google device, run it on an AWS device, get all of your jobs, and get your results with one circuit.
Yeah.
Nice.
And there is this Qiskit provider, right? The open source driven community project. So
Exactly.
some of our research engineers and even the software engineers contributed to that open source software. So if you are a Qiskit developer, right, and then you want to submit a job to the bracket, so you can use that um, provider too. So we believe in at AWS contributing to the open source, right? That is the reason, like, why some of our engineers participated and made sure, um, the the developers who know how to code and Qiskit, they can submit the job to the bracket, so it is seamless in the sense from a user experience of the developer, to keep that in a mind, and then have the same flow of your programming, so you are not changing your style. So it's become very attractive. You can still submit the jobs directly to the bracket endpoint.
Yes, and not only can you submit the jobs with the quantum language of Qiskit, I'm going to show you that you can actually do this with 5 other quantum circuit frameworks, or writing quantum circuit frameworks. So you can, once again, we have a simple Bell circuit, and you can convert it from Circ, which is the Google framework, to Qiskit, and then convert it into okay, and then you can check that the unitaries are correct. So then the results are actually correct. Essentially, this is linear algebra, and you can double check that the results are as expected. So the circuit itself produces the same matrix at the end.
Mhm.
And we can even do a non-trivial example where we have a bunch of various gates provided by Qiskit, and we can transpile it. So this is the Qiskit circuit right here that you see. We will transpile it into Brocket. There you see the output, and we can transpile into Circ, the Google one, and we can actually double check that it's all correct. We can even go even harder. So Circ actually has their own random circuit tester. So this is sometimes used for benchmarking quantum computers, and you use various random circuits.
Mhm.
These are the keyword arguments you can decide to run. Then you have this behemoth of a circuit, and you can convert it to Brocket, then Penny Lane, which is Rigetti circuit. Then you can convert this into Qiskit. Once again, this is quite long. Then you can convert it to Penny Lane. Penny Lane is doing a hackathon right now. I think Amazon AWS is sponsoring that. So there is the AWS circuit. Then finally back to Google, and then Google has their own testing for their unitary circuits and making sure that the results are correct, and it passes as well. Our transpiler was developed by our CTO, and it's probably one of the most robust transpilers across 4 frameworks out there. So we prioritize making sure that the circuit that you get back is correct, and you will be able to see that very soon. I think we might open source parts of it as well. So,
Oh,
Great.
nice.
Yeah.
Yeah.
Yeah, that is one good learning I had today. Great.
yep. So we've been hard at work doing these things as well. Hopefully people will be able to use these for their research. If they are interested in doing a benchmarking across, such as IBM devices, AWS devices, it's very, very easy to do with qBraid.
Nice.
Mhm.
They, your CTO built that whole thing all by himself.
I think he spent yeah, I mean, most of it. I will
Really?
be honest, we are a little startup, but we are starting to hire now. So we have finally gotten some people that will help out, and we have actually found a great intern out of our own hackathon.
Oh,
Yeah, he had some monster beautiful code, and yeah, Ryan, our CTO, was like, we have to hire him. And he's been doing a great job. So
Nice.
that's a really cool part about, I think, quantum computing, is that the community is small enough that you know who's who, but also just you meet the craziest people online and through these community events like hackathons and whatnot. So it's great.
yeah.
Yeah.
Yeah, getting talent like that, I mean, in that sort of way is perfect, because you already know what you're getting, and it gives a chance to a person to just prove themselves right on the spot.
Exactly. And yeah, what you see here, I think, is mostly built by him as well, though. So, but we're gonna expand. We're gonna do some cool stuff outside of this as well. So, all right.
Yeah, I think your CDO, like the transpiler, already got a shout out from one of our viewers.
Yeah.
Oh, nice. Sweet. Hmm. I think one thing that we really want to do is we've been kind of sitting on this for a while, but since
Mhm.
we couldn't, we wanted to show it off, but it was just taking so long to open source because we were just trying to build out parts of our payment platform and our subscription side. But now we finally can. So um, yeah, I think it's going to be great. I think it's something that I've used, and I've used it to do some pretty ridiculous things. Like I think there's a tutorial by Qiskit for financial optimization.
Uh-huh.
And I was just like, okay, what if I could just run it on an Amazon Braket device? Didn't optimize the circuit at all and tried to run it. It did become a really, really large circuit, but the transpiler did manage to write everything back into a Qiskit Braket object. So obviously there needs to be more work because you can't send such a large circuit with too large of a depth or too many qubits. But other than that, it was cool to just see it happen. So
Right.
yeah, not to mention the optimization part and whatnot. So yeah, did I lose anyone?
No, no, no.
No,
Go ahead. We're just I'm just following along at this point.
All right, sweet. So with that said, I think that's a bit of a quick turnaround. We have one small feature as well here. So if you're ever on qBraid and you're like, oh, I don't know what I'm doing with a certain bit of code, you can actually search AWS. You can actually have various Stack Overflow results as well as
Oh,
Google. And so if I look here, I think you guys have a new, I don't know if it's on here, but I saw that Simone's
Oh yeah,
Dr.
today.
Bernie had like some parallel computing thing.
Yeah.
Perminder, you're mentioning parallel the whole time, so I was like, I really want to mention this, but I'm not familiar with the topic. But apparently, you guys have like a new open source SDK available as well. Actually,
Yeah,
I
I
think
think there was a news today. Like we're calling Pascal, like
yeah.
electromagnetic simulation. So, no, so Bracket is y- one of the team inside whole of quantum team.
Okay.
The quantum team
Yep.
out of the CQC out of Pasadena, right? They are doing some groundbreaking work in terms of
Yes, it's
very
this.
yeah. So this just got released and then is open source because we believe in open source. Like if this not only helps the quantum side of the house, but even the classical
Right.
computing side, they can use this to simulate those 3D electromagnetic and all. So you will see often these things getting released from our side.
Hmm.
We have a huge community from a classical side, right? The open source. So some of this is now also happening in quantum side. Some of our research engineers are active contributors, as I was saying in the Qiskit one.
Yes, and I'm just going to do a shameless plug here. We will have C++ implementations in Julia very soon.
Yeah,
And Perminder, would be nice if we could put a little launch on qBraid button here. Wink, wink. Would be
Yeah.
cool.
absolutely. Yeah, I mean the people, Julia or a Python or the Qiskit, right? Like it's up to the developer community, right? Which programming language they choose. What, as an enterprise, we believe is like giving an access, right? Like the language which you're comfortable and use that. Um, we don't want to limit anyone. That is the reason we work with firms like qBraid when we
Mhm.
do the hackathon, right? It's not like just we want to do the hackathon. If you see the story which you are telling about out of a hackathon, somebody coded and that person got embedded into the team. That is a big story. That is what we believe in building the community. This is what I was trying to tell by my crowd intelligence, the high schooler, the university students. They are vital workforce, and we are going to probably struggle in next 3 years when this are becoming into the mainstream. Everyone will be trying to get those resources And this is one example. There was another example. I believe you guys also participated, and I was actually a hackathon participant in that with Romanian last September. That
Yes.
hackathon happened, right? And there is a nice story there. One of the students who participated in this hackathon, right? He also got embedded into one of the company who was sponsoring that hackathon as an employee later on in the Europe. So those are the some of the um, outcome or output we at AWS believe in, like how to make sure we have the bracket also qBraid solution also, but at the same time help the community grow, right? Because we need all the firepower to make this happen, and it will happen, right? Means I'm positive. I'm very optimistic. It's not about if, it is about when. And then I'm sure somebody announces something in next 2 years, the qubits are, million
Yeah.
numbers,
Yep.
and then the race will start, like how to protect your encryption and all that thing, as well as people would be trying to build some optimization algorithm as well as the gate based optimization, right? Whether this is like unstructured search in the list, like databases using Grover, or HHL for complex problems. So it's not a question of if, it will happen. It will happen, right? But we need to prep for that. And then this open source contribution, you will not see direct impact today. You will see this mass adoption as people start using it, and then merit of the solution getting open sourced, the outcome of the success will be measured by how the community adopt it, right? And how does it fare? It's a stand on its own merit. But we at AWS believe like we need to share those artifacts. That is the reason this Pascal was shared, and that is the reason why you will share the transpiler, which you have. It is the unselfish contribution, right? So we sometimes underestimate that work. Um, so that's what I think I wanted to say
Mhm.
on this topic. Long answer, but
Basically, I'm almost going to make it like the unofficial uh, motto of the show is "No one is an island." Um, just having, and I also love. I love the balancing act we kind of do. It's not just with qBraid, but the balancing act we do between like open source, creating stuff for everybody that we can all build on, and then being able to leverage that open source to for companies to actually build products with. I love that kind of give and take kind of idea thing that we just do in general in this industry.
yeah,
Yeah, I think as Parminder, you mentioned, like it's a pretty niche technology. It's still starting out, but it will catch momentum. It's not a matter of if, but only when. So it's cool to see qBraid leveraging like AWS to help spread this importance of this technology out.
yes,
Yeah.
absolutely. As you guys heard, right? K-12, White House adopting this software. There is a reason behind it, right? Means somebody, apart from me, outside AWS or outside qBraid, saw the potential of the software. That is why it became the or became the leading solution which White House adopted. And there is another piece of information. Ryan, the CTO behind this, right? Like he created the solutions. But there was one. Some of the industry folks know there is a World Congress on quantum, which happened in DC last year. I think I'm forgetting the date, Ricky. It was November end, right? November or October end?
Yes, if I recall, it was before a big conference called Q2B.
November,
So it was
right?
definitely in November. I think it was like
Right
17th or 18th.
before, yeah, right before our reinvent, and then qBraid CEO Kanav, right? Kanav
Yes.
Setia. He also got he was the finalist and got awarded the best startup in this quantum. So that is a big big thing, because some of this company, including the qBraid, right, they came from this whole startup duality accelerator and all. They use the AWS very quickly to launch the prototype and make it production grade. But at the same time, coming from the World Congress, Quantum World Congress out in DC, is a huge brand building for qBraid, right? So there is a reason why this software is popular, and I highly recommend start using it and then experiment it and then leave feedback. Um, Power of the software is again like abstraction at a level, so that I don't have to worry about my local Anaconda or manage to Jupyter notebook, some of the things.
Yeah, having those environments. I mean, you can always manage them yourself, but that's one of those. What's that famous where we use undifferentiated heavy lifting
Yeah,
that we don't want to touch as much as possible.
yeah. I mean, so if my job as a researcher is to simulate the hydronium or hydrogen molecule and study the molecular decomposition of those systems, right? Study the ground state energy and all that, right? Or the annealing for the optimization. That is my day job. Why I should waste my time putting access key there and then running the pip install and all that? Means obviously somebody will do that, but my job is like to quickly experiment it, benchmark my experiment. That is where this share better, and for the researcher in the corporate or the university, as a high schooler or even is a learner like a person like me, right, like or you, right, like who wants to learn quantum computing, they can use this software, the QLearn module. So Ricky, are we covering your lab thing too?
That's about it. I just wanted to show one more thing. So as of Monday, we now have subscriptions available, which will provide you variable compute. This is again through AWS. So I'm on the standard plan, but everyone is given one virtual CPU and 2 gigas of RAM. So that's your free version. But as you have more, we will provide a little bit more compute. And if you are on our premium plan, we will soon, hopefully by at least in the next 1 or 2 months, have GPUs ready as well. And for enterprises, if you're interested in maybe even having this kind of Jupyter Lab environment available for your team, maybe they want to get exploring quantum computing, maybe they are actually interested in having that environment for TensorFlow or something, like we would be happy to just kind of discuss that as well.
So you said that the standard there's like a free tier.
Yes.
You were saying. What does that kind of look like? What is included in that free tier? Is it time based? Is it cycle based? I don't.
Yes. So the free tier, you get the one CPU that is mentioned here.
Yeah.
It's a limited CPU. You get access to some of the environments that are added. So these are like the default environment, as well as you do have access to quantum jobs, but you are not able to, say, share notebooks or access the search feature, which has like Stack Overflow, as well as Google. You may be limited in your search bandwidth there as well. So those are the things where you saw everything that you may want in your standard feature, and then we just kind of have the limited feature that's really for anyone that's like just getting started.
Oh yeah, I mean, yeah, that sounds like plenty. To get started and just at least poke around and be curious with everything. Excuse me. I'm gonna drop this in the chat one more time. If you're just tuning in, I think we're coming a little bit towards the end, but we're with our partners at qBraid. They're showing us their quantum computing platform that's utilizing AWS Braket, and I'm going to be dropping in some links. You can try it out for free. Ricky's given us a code for some free credits, and there's labs included in there. Everything to check it out. Let me go ahead and get this in.
And that kind of consists of all that I had to say today.
Yeah.
So we covered three main modules, right? Like the qlearn, which we saw in the beginning, and then the qBraid SDK,
Mhm.
qBraid lab. So for the community, I think I know the answer, but for the community here, can you describe a potential use case when they should start with lab versus SDK versus the learn?
That's an
On the
excellent
persona
question.
of the person, like if he's a student versus a research scientist and big pharma.
That's an excellent question. I think everyone should start off with lab. And so that's where you would be coding. That's where you can actually have most of the resources that I showed, including the tutorials, as well as how to access Amazon Bracket quantum computers. And then if you are an academic, you may
So
want
you meant qBraid learn, right? Not lab.
yes. So qBraid learn, yes, we have like a learn side, but that's the QBook that I showed with the videos and stuff.
Yeah.
And we actually have that, but we don't really push it that much. I think it's just kind of there. And on the lab side, get started on like a free plan. And then if you want to do the academic side, I'd recommend the standard plan. And then if we can actually do some more tailored consultant as stuff to not only like customize your Jupyter Lab environment or your qBraid Lab environment to have various files that are necessary or various hardware that's like specifically available for your device or for your needs. And then, of course, we have our Pro plan as well for more enterprise or people who are really looking to use some hybrid algorithms, for example, or like some high compute as well. So
Great. So if you are a enterprise customer, right, like some big financial or a pharma, and if you want to do some internal, not the public facing, but then internal hackathon or internal knowledge building for your team members, that can be still be done via the qlearn platform, right?
yes, we also do hackathons as well for enterprises, and if you are interested, it's actually one of the best ways of getting started because not only do you get people who are experts kind of show you through a use case, and not only that, but what we can do is you're learning, I think, from at least for me, it's what's best is I think what would be great is you get to learn as you do. And something that's really as confusing as quantum computing, you have so many avenues actually to learn it from, such as from the computer science background, the mathematical background, the physics background. And it's really like you get a tangible feel for how you feel best about how to approach it through just like doing it. And I think hackathons are really great. So yeah.
I know.
Yeah.
I know. Some of the topics are so complex. Or there is so much misunderstanding, specifically around entanglement, the teleportation. So sometimes first time you say, like, oh, all the weird things, right? How can that work, right? Like where the power of this is coming from, right? You will be shocked at once, but I think if you're curious enough, start experimenting it and then try to understand the math behind it, the physics behind it, quantum mechanics behind it, those will come naturally. It took me like 3 times to understand three different way, like a book and a YouTube video and some paper to understand the whole concept of non-locality, like the whole EPR paradox, like what the heck this is. So this is a complex undertaking, right? Quantum computing is not. I will not underestimate. It took a 2 year or so for me to understand some of the basic thing because the whole notation around bracket and all will throw you off day one. You say like, what the heck? How these guys are doing this? It will not come naturally on first day. So I think my advice would be like to use software like qBraid, experiment it. If you don't get some concept, fine. You can run the circuit, come back, and then start applying those principle like Bell circuit and then whole teleportation, super dense and all, and then go back and read, right? Cross check what you were doing in a circuit, and this learn module had those example, and as well as the theory behind it, right? So all of those under common roof, side by side, is going to speed up this whole knowledge acquiring process, at least for the student. And for the mature learner, like some of the PhD postdocs who are really focusing on, yeah, I gave an example of that whole molecular decomposition and all that, right? Some of that work or like a complex optimization problem you're trying to solve, like a work scheduling or a hospital nurse scheduling, like that. This platform also served that kind of an audience too, right? It has this level which satisfy the high schooler, but then the platform is mature enough, the lab, and then this whole SDK, and then cross sharing those notebook across two continents.
Mhm.
Is a production grade. So you are doing it all under one common roof, and then you organizing a hackathon internal facing at your company between six different teams spread out all over the globe, right? Like you can use this software in multiple way. Okay, so there is a use case for everyone, and I had a great learning last September as I was using this for my hackathon, right? And then the solution got launched last year. And right now, we are working together with my business lead, Safin, and I, and then this qBraid platform, your side, Ricky. It has been a great experience. And this session which you guys arranged, James, is one step in that direction, like how to make sure the community knows about this software.
Yeah. Cool. Yeah, this was great. Was there anything else that you had planned for us today, or are we
Nope.
kind of heading towards the end here?
This has been great.
Yeah,
Thank you, James.
I'm still not an expert, but I definitely learned something for sure. And
Great.
I love one of the things I love. I mean, this doesn't have as much to do with it, but I love that it's all self-contained. The platform is in a way like you don't even have to leave for the documentation or search Stack
Yeah.
Overflow or whatever.
Yes. Oh, yes.
I mean, people like their own things. People want their own extensions, their own environments, whatever. But I like that, just out of the box, like it's just you don't really need anything else. That's super helpful, especially when you're getting started, especially as a learner.
Yeah. I think our team is basically full of developers, so we like it's also fun to just build what you would want, and it just ends up being self-contained, I think. And just to further emphasize that, we have like all of our documentation here if you need it on the help page as well. So that's all available.
Yeah.
I have to admit, all my knowledge on quantum computing was primarily from like sci-fi movies and books, but
Nice.
I think you have convinced me enough to just like get my hands dirty, because this was really
that's great.
interesting.
It's a fascinating. I mean, if you get through that initial hump
Yeah.
of math and then the physics, you can always go back and do. There is enough literature and on YouTube and books and all. I think you should not stop. You should take that second and third leap of faith, right? And then think like, okay, pick up a topic like entanglement. Why the heck that entanglement is there? What is teleport? How is it gonna affect me, right? Why did Einstein fail to explain the theory, and he used hidden variable theory to explain the spooky behavior in a distance, right? Some of that we learned when we were in the physics class in our 10th or 12th grade. But then fast forwarding, at least for me, I am revisiting the topic, and then now quantum mechanics fundamentals are helping me to understand that, right? The work by Bell, Alan Aspect, and I always forget two other scientists' name, which is not fair to them, and they won collectively, right, the Nobel Prize for Physics last year. So this tells that, like, how the industry has grown over the 100 years, right? And then how people are noticing now. But there is a downside to that. Like lot many times you will hear like some of the hype and some of the wrong information.
Yeah.
The legends of the quantum, John Preskill, right? He is our AWS Amazon scholar, right? And he is supporting us from the Caltech side. We have our visiting scholar James Whitfield from Dartmouth College. Check out his um, quantum computing courses, right?
Yeah, James was also Kanav's our CEO and co-founder's advisor.
Right. So there is like a little bit of professor, teacher, and then how people have grown beyond their PhD and formed the company. So Kanav has a check out his profile, and then you'll see like how he has founded his company, and then how people have grown. So John Preskill, Scott Aronson is another person, who I follow a lot. Like, okay, he tried to explain. He he's a legend in his field. Now, out of University of Madrid, where I am studying, like my professor who taught me this cryptography and communication, it's a brand new subject. So he's a student of Ronald D. Wolf. Ronald D. Wolf is a student of Harry Berman, who is a legend, right? So, so all of this, you will initially feel initial 3 months like, why the heck I'm studying, like what its value. But once you start going into it, and the software and qBraid's platform and AWS and all will be there. But as a student, your job is to experiment very fast, right? This QLearn module come into play there, right? And designing the circuit and all, and then you can always go back what you learned and experiment. It is like a, back and forth, back and forth. If you do it 2-3 times, I think all the concept will start coming.
What we like to call here at AWS, learn and be curious. So just constantly keep learning.
Exactly.
Yeah.
Yeah, I mean the story is vital because I could have lived in my classical world, because I was there for 20 years, right? Like I started like 20 years ago, all .NET Java doing. I could have been comfortable, retired there, not paid attention to what is happening at the quantum side. I started like 2 years ago, and then there was this seminar by one of the company where heard the CTO explaining quantum and the nature, why we can't explain everything through the classical by Newtonian law, right? So that is where my curiosity started. I felt like, what the heck he's saying. So this whole law which are followed in quantum mechanics at the nanoscale, the atom and the molecule, right? Like those are sometimes we take it for granted, right? At least I took it for granted 25 years ago when I was in my 12th grade, right? I just passed the subject, no one was paying attention to, right? But this concept was such a eye opener to me. I took that leap of faith, and that story is a vital story to tell to the audience, because there are some of my colleague who have been in this industry for 20-25 years, right? Like, and then going from there to the quantum, it will take a little bit longer path than if I would have been in my high school now, right? Like so, and I have a qBraid platform. I'm in high school right now, thinking like that. So I would easily learn. But sometimes, like people like me, like it takes like probably 2 years to unlearn something and then learn the new stuff. But we need everyone, right? We need the high schooler. We need person like me. We need person like Ricky, and then Kanat forming the company. And the enterprises of the world to come together, because there is a race, right? There is security and some national security implication, as well as you can actually speed up the drug discovery, right? Some of the use cases people ask, like, what do you mean by drug discovery? It's very hard to simulate a molecule on the classical, and then how does that affect the discovery of a drug? Means there is a cycle, right? Why 10-12 year you have to spend on your research, and then heavy part of that is spent by pharma research scientists in the lab simulating it, because you can't simulate fast enough. You're all what if scenario, right? some of the logistic side optimization problem if you are a company like a who deals with a last mile package delivery like our own Amazon. We always are trying to think like optimize the driver time in delivering a packet across, for example, 10 different location, right? And the minimum amount of time is a hard problem. It is sometimes it comes from the complexity theory, right? What is P and NP and all that? Those come from that background. We'll appreciate there is a quantum side, there is a classic side, but this would not be possible just purely with a classical resource. Otherwise, like why do you need quantum, right? I mean, there is a need of the quantum. Are we there yet? We will know, right? Means how we fare in terms of qubit and mitigating the error and suppressing this error and all. But I'm sure someone somewhere in a garage is building a next generation computer which is way beyond the power in terms of like 300 or 400 qubit which we have today. Someone announces next year like million qubit, 10,000 qubit, like that. As we progress next 2 to 3 years, we run out of time, right? Like we are then just trying to play a catch-up game.
Yeah.
And then qBraid has been early starter. They have the advantage, right? And that all were possible because of this mutual partnership when our worldwide SO Michael Brett identified them at Duality Accelerator. They funded, and then other pieces started coming together. Cloud way of all this software, all this website which you saw, right? It runs on the AWS cloud. So there is a bracket, but you have to run it, your main web service, the API and all that. And that would not have been possible if you are, not using a cloud. So cloud and quantum and classical HPC all has to come together, and they'll come together. And who knows, as I said earlier, in 30, 40 years from now, we are all in quantum, hopefully.
Yeah. Yeah. That I agree with everything you're saying, and I appreciate getting kind of getting us the step back and giving that higher level of what's behind everything for sure. So before we close out and end the show, is there anything you'd like to plug? Anything else? Do you have a LinkedIn for yourself?
Oh.
Anybody? Check out qBraid on LinkedIn. I'm following them. Are you TikTok famous? Do you have
No.
something like that?
I can drop our LinkedIn and my LinkedIn as well if anyone wants a message, and our Discord. Does that sound good?
Oh, you have a Discord too? Oh, okay.
Yeah,
Awesome.
we have a Discord.
Huh.
So
Awesome. And I would like to point out that we dropped 2 surveys because that's what we do. AWS, we just love our surveys. One for Ricky and qBraid to
you.
get some information, get some signups, get some more credits. Maybe I guess you'll have to talk to him and find out specifics about what that is. And then our own survey for Howdy Partner. Please fill that out. We don't know how to get better. We have unknowns. We can or tell us what you'd like to see. If there's any partners you'd like to see on here as well. You can check me out on LinkedIn. I'm pretty easy to find. James Spencer, AWS. If you want to connect with me, I'm not TikTok famous, but
Pretty soon, I hope.
I don't know.
Yeah, please reach out to the community, right? If you're a developer, you want to get engaged, you have Ricky contact, and then if there are more mature audience in terms of like enterprise customer or research scientists, please feel free to reach out to any one of us, right? If that has to be done, like the last piece, the Q lab which we saw, right? Like for the enterprise, now we can get something done and one-on-one setting, right? If experiment is big and you need a dedicated attention to that. But yeah, please experiment, learn, have fun. Quantum is good. It's challenging, but it's good.
Yeah. Anything from you, Aniket, before we close out?
No, yeah, just want to thank Ricky, Perminder, and of course James for this session. I think this is really insightful, and I look forward to seeing more stuff from qBraid.
Sweet.
Cool.
Yeah.
All right.
Thanks, Ricky.
Thank you.
Thank
We'll see
you.
everyone later.
Bye-bye.
Thank
Thank
Have a
you.
good day.